Start of a new year, start of a new series, our carbon diet. This is going to get pretty extensive. We're talking about how to lower your carbon footprint of your housing. And this is going to be a very interesting project. This house was built in 1990s as a passive solar house, but its energy bills have creeped up to over $500 a month as a minimum. This is outrageous. I mean, you just take a look at things. One of the condensers died, and that's how we got started here. But it has multiple problems throughout of it. But first, we're going to take a moment to enjoy the beauty of where this place is really set, on the side of a ravine by a river. And now, inside the foyer, and with the powder room with the doors, the light on, the powder room has never heated. It's been always cold. And this is one of the main features of this house, is this beautiful stairway that starts in the basement, goes to the foyer, and then from the foyer it goes up to this third level, which is the master suite. All open so that air can pass all the way through the house very nicely with the solar gains and all of that. You notice how that is all. But this makes a beautiful dynamic air shaft through the house, allowing the air to move through the house with natural convection. At the third floor, looking out, you can see the patio off the master suite. We also have a fireplace in the master suite. There's 8 tons of cooling here that services this house. We have 2 systems. And one thing we only have one of when we have these 2 systems is one return air was put in for both of these systems, and this house is built right behind that light fixture. We need to address this. Here we are on the 3rd floor, and you're looking at the thermal pane glass, which is 1-inch thermal pane, low E. Moderates the solar gain in the summertime, but not a lot. There's a lot of gain in the summertime. But it is a good part of the passive solar coming in there. On the opposite end of the house, in the northwest corner of the house, we have another shaft that goes from the basement floor, and is beautiful, all the way up and out. This is the north side of the house right here, facing that way, and the west side is the back. So they had a call for help to try and straighten this out, and that's why we're here to fix the problem. Welcome to Let's Really Teach HVAC. This is a new project that we're doing. We have a beautiful, lovely house, as you saw from the introduction, and you will see by the following pictures. The house has had an issue with a massive cost of heating this house and being unreliable. The heating is not real steady, and we have a lot of issues with it. So from this point, I'm going to tell you what I found. I did a bunch of detective work, and you just saw all of the pumps, and this is the water heater for this unit, and this is the boiler. We have a Flareup boiler, which I really like. I think they're a very fine piece of American-made equipment. This is a cast iron boiler. It's about 20 years old. So we have the 20-year-old technology with a fluid damper and the whole 9 yards. Nothing wrong with that. What we're running into an issue here is we cannot control the temperature going into the radiant floor heat. The radiant floor is really overheating, and the homeowner, who's very smart, has learned how to adapt to this overheating, but it hasn't solved the problem. He just adapted to a broken system. Not his fault. So, the system, we are in a place called Ypsilanti, Michigan. We are in a very, very union town. We have lots of union heating contractors, union plumbers, that type of thing. This system cannot be installed by union people. It would take like 4 companies to do it. So unfortunately, it was installed by someone who had a little less control knowledge than was necessary. And it was all laid out, and the architect had laid out how he wanted it done. Right here. So this is a mixing control. I put in here, I'm not sure exactly what brand it is. I'm not sure exactly what it is, but we have the hot water coming in this way, return water coming in this way, and mix out. The adapter piece, or whatever it was here, is totally disintegrated and rusted off. It is not adjustable in any way, shape, or form. I have looked at the temperature with the mercury thermometer here, and it's running between 120 and 140 degrees. And this is mild weather, and that's way out of hand. So what we have to do is, this is an issue with mixing valves that are not electrically controlled or whatever, because now it's got to be a major plumbing in order we could change this and put this back. But how long this lasted is a shame, because you see this rusted apart. Even though this is all brass, costs you a fortune. If we put electronic, and what we're going to put in here is we're going to use a Techmar control, and we're putting in an injection loop. Because the injection loop, if something went bad, it would be a sensor, an electronic control, or a pump. Everything easily replaceable. This, up against the wall, where it is, the way this is put in here, it's not easily serviceable for anybody. This is a 120-gallon smart tank by Triangle Tube. It's really good. It works very well. I've used many of these. It's a little oversized for this house. It produces way too much hot water, and it's not piped exactly correct. We will address that too. One of the reasons I've checked this house up, down, sideways. We've taken floor temperatures and everything. This house is grossly overheating in certain areas. So what's going on here? We're talking with the homeowner, what he has to do to maintain this very bad system.
Okay, well here we have the expansion tank for the system, conveniently located on the floor underneath the piping. Great place to go if you have to remove it. That's why we want to change all of this, put it up to the wall. One of the things I noticed is, back up here just a bit, and you can see the flue pipe. Well, we're going to pull that piece out, put the T up there, take that piece, put it down here, raise it up, and take the flue pipe up and out of the way, so that'll clear our wall out and give us enough height to put in all of our pumps and everything on the wall.
Okay, the problem we have with the domestic hot water is that off the bottom of that T, you're running through the boiler pump before you even get to the domestic hot water pump. That won't work.
Going back to this is the pump control for the pump for the domestic hot water. When this was put in by the plumber, he didn't realize that the tank came with a sensor. So we got an extra control that's been here for 25 years on the wall. So there is a remote bulb. Look where it is. It's on the pipe. Why would it be on the pipe? This is really strange.
All the pump flanges are 3/4 copper, but all the pipe is 1 inch.
Back to the room here, and I took we have a thermometer right here, and it's 100 degrees in the room, just about. This is worth a waste of energy here we're talking about. We're taking the thermostats off. These are Honeywell T87S, as everybody knows. The last in the series, T86A was the first one. It was before most of you guys were born. And these are good thermostats. And I know that there's longevity on these. Well, I'll do any digital thermostat in the world, bar none. So, but can't program them. And here we are. Now this is why we got in here. I'm looking at seeing what wires we have. And there's my secret. That one right there is going to allow me to put a new thermostat up here. Because for air conditioning, you got white, green, and red. And no white, obviously. And the white will be my common. And my common will allow me to get a wire over here and put in a brand new Tecmar stat with the sensor in the floor. And so long as I had those two, I can get all of this connected. I'm very happy. I'm so happy that I can put the actual thermostat up here, not just a sensor. Because this will only have two wires here. Will end up being the end switch downstairs. And then we have to put a sensor wire in and then power over. Thanks, you Nest. My favorite thermostat screwdriver. I have a client that I put in Nest for all the time because it ties into his other electronic systems that he installs in the house. So I've been getting a lot of this thermostat screwdriver. Okay, here we are picking up from our video. We're talking about the thermostat. This right here was the original thermostat connection from downstairs. That just makes the end switch downstairs, and we'll make the end switch again on the new thermostat. Here we have the sensor wire that we put in.
Tecmar has every type of wiring diagram that you need that comes with this stat, so you do not have to guess. Everything is perfectly clear.
Well, you can see that we have a steel beam on the far right. Next to it is a wall running perpendicular away from us. And the next stud is the side wall stud from a short wall that's right here. And we ran, if you can see, we ran the sensor in the wall right down at the floor line there. We drilled in about 6 inches down into the concrete through the 2x4 on an angle and set the sensor in the cement. Not next to the steel beam, which has a separation. So
Some people might be wondering how we knew where to drill these holes. Well, I actually have the original layout for the tubing, which we checked out on a few things and found out that it was pretty accurate. So using the original layout, we knew where the tubing was separated for the different zones.
Here's the front door. This is the entrance foyer. This goes into the back way, into the kitchen. And right there is a thermostat. This is the one that we replaced. And this is the one that was marked bath and foyer. And as you can see from where we're at here, it is right there in the proximity. The manifolds are located in the closet right there with the bifold doors. I turned on, came back to this thermostat here, turned on the end switch, which turned on the pump, which turned on one manifold. And that manifold should have been heating the bathroom, the front foyer, the kitchen, and this area. But no, it's been mismarked for 25 years. And so this thermostat here actually controls the temperature within the living room. And so that thermostat controls the temperature in this wood floor, which is very good because that would have to be maintained differently than the ceramic floor that is controlled by the other thermostat. So where is this other thermostat? The thermostat that we're talking about, that we're looking for, the missing thermostat, was actually right here. I installed a new thermostat. We took the old one out, put the wires together. We came down and I wanted to put the sensor into this brick floor because this is what that thermostat actually controls, which is the brick floor for that, for the kitchen, for the storage room, for the front foyer and the bathroom. So in order to get the thermostat in the floor, I put a hole down in there and we put the sensor into the drilled through down on an angle into the concrete floor underneath the brick. And you can see that opening there. And then we ran the sensor up the wall and it works. This is our infamous mislabeled pump. One pump was labeled for your pantry, the powder room pump was over here, so we found out that all of this is on this one pump. So it's powder room, kitchen, foyer, pantry on one pump. That's where I just put in the sensor in. So right here is where that sensor comes down now. This is where the sensor comes down, and this is the end switch. So this is how where we're going to put the new thermostat is up here.
Using the Tecmar wiring diagram that comes with everything, we're taking the 24 volts that we need for the thermostat off of the Taco pump control, which has connections for that.
The back plate on the right is the one that I've been working with for 2 days, and I kept coming up with errors on everything you can think of. I changed the sensor twice and put the sensor directly to it, and I still got errors. I took the thermostats out of 2 other boxes and tried them, and then I said it's got to be in the back plate. If you see this back plate here, see how the writing is slightly off and you got 2 slots on each side, and you can see how the writing lines up with the screws. You see that? And I got 3 on this side and 1 on that side. Not 2 and 2 and not misaligned. This really threw everything off. I just switched out the back plates, and guess what? The thermostat works. The sensor is upstairs, the stat is down here next to the pump control and everything. It's the only way I could do it. I was really worried that this wasn't going to work when this thing didn't perform the way I wanted it.
All right, here we are in the basement. We have a thermostat around Honeywell T87F. I almost said T868, it really dates me. We have a new Tecmar. We're going to use the 519 here. The 519 radiant thermostat with the sensor. Now we only have a 2-wire here, and if you look down at the floor, we have concrete on this side and brick on that side. Now this, we want to put in a floor sensor, so I don't want to drill into the brick. I have a problem with that, shattering maybe. So I drill a hole, the opposite side of the wall, on the thermostat. We're going to take the stat off. We're going to drop the sensor down. We drill a hole. I'm going to drill a hole on an angle into the concrete slab, and then in place the sensor, and then go into the furnace room. And the stat is gone. We connected the wire nuts together. We wired the two wires together from the sensor and from the thermostat. Then we came down here, and with the drill, there it is. So there's the sensor, it's in the hole, and the stick is what I'm putting the caulking in with, and we're done here. And then we'll just put the plug back in, and the sensor will be in the floor into the concrete.
As you can see, the temperature is still warm in there, and the temperature is still warm at the stats. So once we program them, which are really easy to do, by the way, I programmed all 6 of the stats. You program the stats that are on the wall, the 2 of them that we have, one in the basement and one in the main floor. differently with the stats up there than you do with the sensors only, because they're going to read differently. The thermostats that we have in the boiler room are programmed for sensor only, and that way it's only doing the floor. The other ones are programmed with sensors and room temperature. So all of that is very easily done, very easily programmed. And after we got this done, the room did drop seriously a good 25 degrees or more.